start talking about Chapter 8, which is Managing Flow, Variability, and Safety Capacity. What we've been working on has been more of the manufacturing, kind of the examples that we've given, and so this specifically relates to services, okay? And what you'll find at the beginning of the chapter, there's an example, an LL Bean example about customer service, and basically what they're finding is that they're having customers that are getting busy signals and aren't able to get through to their customer service, and they're talking about the impact that that has. And what I think is very interesting about Chapter 8 is as we move into the third part of it, the third lecture, we specifically look at how there's quantitative ways to calculate what happens given your arrival times of customer calls and how many people are going to be blocked from service, and then we're going to look at how do we calculate what the cost of that actually is. And so again, I think that's a pretty relevant issue when you're talking about customer service, because there's a certain amount of people that are going to either be blocked if it's a phone call, or that are going to walk up and see how long the line is and turn around and walk away, right? And so this chapter actually shows us how we can assess that quantitatively. So our previous assumption is the product being supplied can be produced and inventoried in advance of the actual demand, okay? In cases like LL Bean in our financial aid office, right, that might not be a valid assumption, right? The financial aid office can't actually perform services and store them and wait for somebody to call upon the need for them, okay? Our business processes are defined by inputs, outputs, buffers, and resources, right? And we have our key operational performance measures, flow rate, which is the same thing as throughput, flow time, and inventory, right? Those should be terms that you're all very familiar with at this point, okay? Previous chapters we studied make-to-stock options, right? And this chapter we're going to take a look at make-to-order operations or service operations, okay? And for the university bookstore, when a previous team evaluated the service of when you take your books back, right? I think they say their busiest time periods are from 10 to 2. They actually don't have enough cash registers in place from 10 to 2 to service all the customers that they have coming through. So if that volume were there all the time, they would have an unstable process because their lines would just continue to grow. Okay? And that was probably 2 or 3 years ago, and they've made some changes definitely since then. Okay? But when we study service processes, and today is going to be mostly about the terminology and understanding what the different components of it mean, we have customer arrivals, okay, or the inflow of job orders. You have the server or the resource unit that processes that customer arrival, and you have a queue. So that's the inventory of inflow units that accumulate in the input buffer because you don't have enough processing capacity. Okay? Okay. So your customer waiting occurs for a variety of reasons, right? And so as you're looking at a process and you're trying to understand why people are having to wait in that process, you're going to be thinking through things like, well, is it because that we don't have enough capacity, okay? Is it because, well, let me just ask you this. How many of you go to Walmart and still use the checkout lines? Anybody? Yeah? So how do you decide what checkout line you're going to pick?
Depends on usually what side I parked on.
Okay, what side you're parked on, so location, okay?
And I guess who's in line before me.
Okay, how many people are in line before you? So that's there's variability in customer
Age
arrival
of the
times.
checker.
What's that?
Age of the person that's doing this,
Age
because
of
if
the person
they're
make an assumption based on or knowledge of, you know, this checker's good and you know this one isn't, right? I've been in line with that guy that talks about every item. Oh, so you got cookies today. Oh, so you got, right? He wants to be in that line, right?
oh, so you could get some certain items and really make it interesting.
But basically, if you think about why you pick that checker, has to do with variability in processing times, right? Everybody doesn't do everything exactly the same. And so if you know that there's a good checker, you know that they're going to process much quicker. But when we look at the overall process, we have to understand that processing times differ because of the people involved in it And sometimes because of the items that you're purchasing, right? Sometimes it just takes longer, like if you've got a lot of sodas that you have to pull out of the carton, right? Or, there's more steps that have to take place when you do that, okay? So you have variability in customer arrival times, which is why those lines are sometimes longer. You have variability in processing times, right? And then if you think about it in a manufacturing environment or service environment, which has more variability in the processing time? Manufacturing or service? Service. Yep. And again, I think I've used the example in here before. When I had small children and I would go into the bank, my goal was to get in and get out in the least amount of time so that my small children didn't have, run wild or, trying to keep them under control. On the other hand, if my grandmother's in the next customer in line, right, she's going in and her approach is, hey, I haven't talked to anybody in the last 24 hours, so I'd really like to, visit with the teller for a little bit, right? Very different in terms of, and basically the process that we're doing is, if I'm making a deposit or she's making a deposit, that process is the same, but basically as a customer, we're very different. So a process manager has to balance that cost of reducing the variability with the cost of increasing process capacity, because a lot of times the easy answer is things like, well, let's just add more cash registers, right? Okay, so that seems like for the university bookstore. Okay, but there's cost associated with that. So are there ways that I can reduce that variability, right? And one of the suggestions that we made to them is that they offer a discount or a promotion for students that come in from 8 to 10 in the morning or from 4 to 6 in the afternoon, to try to spread out so that you don't have everybody coming in from 10 to 2 o'clock in the afternoon, okay? In this chapter, we're only going to look at a single activity process. Each customer is processed by a single server, okay? So a single-phase service process may have multiple servers, each performing the same set of activities on one customer at a time, and they can have a single queue or a multiple queue. So when you think about that, think about when you go to Wendy's, right? They have kind of you have to get in line and you have to go through the cattle gate, right? That's a single queue. When you go to McDonald's, right, and Wendy's may have more than one cash register open, but you still have to follow that process. When you go to McDonald's, right, you walk in and they've got 4 cash registers and they may have 4 lines for each of those cash registers, right? So you have, and just from and I haven't been to either in a while, but I find Wendy's is, as a customer, I understand exactly where I am in line, right? There's no, here's the line, here's what I'm doing. And I haven't been inside the new McDonald's. I've been through the drive-thru. But the way it used to be is you'd walk in and there'd be all these people milling around and you weren't really sure who was in line and who wasn't, right? Or, are you in line or what am I supposed to do? And so as a service manager, you need to think about how that arrangement affects the flow of things, right? It just takes people longer if they have to figure out how it's supposed to work. Another term that we talk about in this chapter is service order discipline, okay? And that just means what's the specification of the sequence in which customers are served. So we talk about first come, first served. I walk in the door, I'm the next one served, okay? In this section, we will assume that all customer arrivals can be accommodated by the input buffer and eventually served, meaning that we have a stable process, okay? In 8.7, later on, we start to address what if we have to turn customers away? What does that look like, okay? So in a single-phase service process, customers arrive, customers wait for service, and then they're processed, right? It's a pretty straightforward approach. Okay, now we get into the terminology. R sub I is our average inflow rate of customer arrivals per unit of time. So it's customers per time. Okay? So our average inflow rate, R sub I, okay? And if somebody says our inter-arrival time, that's just the inverse. It's the time between customers, right? So if you have to calculate one, or if you've got one, you can get the other. So if I know how long between customer arrivals, if I take the inverse of that, that gives me the average inflow rate or customers per time, right? Or I can think about the inter-arrival rate, which is time between customers. Okay? T sub P, we're talking about the processing time, right? So it's the average time required to serve a customer. And in a single-phase activity process, the process time is equal to the activity time, which is equal to the unit load. So we kind of are linking across the chapters there. Okay, and so then the inverse of our service processing time is the unit service rate, or the processing rate. Okay, so again, T sub P is the average time, right? And then 1 over T sub P is how many customers we can process per unit of time, or the processing capacity speed of each of those servers. Okay, so again, terminology-wise, little c represents all the servers that are there. So like if you're at McDonald's and there's 4 people at the cash register, your C is going to be 4. Okay, and then R sub P is your service rate, or your process capacity. So R sub I is your inflow rate of your customers, and R sub P is your processing rate. Okay, and then so when you think about if you have a pool of customers, right, then R sub P, your processing rate, is going to be the number of servers you have divided by the average processing time. So let me just do that in an example. If I have 5 servers and it takes me on average 5 minutes to process each one, right, my average processing rate is going to be 5 servers divided by 5 minutes, which says I can then do basically 1 customer a minute. Okay, so again, we're just getting at that relationship that says the number of servers that we have matters. Okay, and you can interpret that as scale times speed, right? How fast can I process and how many do I have? That's what we're working with. Okay. So service performance can be discussed again as in terms of throughput, flow time, and inventory, just like what we've been doing all semester long. Okay, and flow rate or throughput is a related measure of process capacity. Okay, so it's the average rate that customers flow through the process. Okay, our throughput is typically whichever one of these is smaller, right? Is it because if my inflow rate is lower than my processing rate, right, then my throughput is going to be equal to how many customers I have arriving. If my processing rate is the cap, meaning that it's not fast enough to process as many customers as I get, then that's going to equal our throughput. So let me try to give an example of that. So if I'm at McDonald's, and let's say that my processing rate is maybe, let me think about how I want to do the example. So let's say that my inflow rate, let's go back for just a second, that my inflow rate is going to be 5 customers every minute. Okay, but my processing rate, I can only process 4 customers a minute. It doesn't matter that I'm getting 5 customers in, my throughput is still only going to be 4 customers a minute. Okay. On the other hand, if my processing rate is 10 customers a minute, and I'm only getting 5 customers per minute in, my throughput is going to be equal to how many customers I have that are arriving, so my 5 customers per minute. Okay. They're not a hard concept, you just have to get your head around what the terminology means. Okay, and so then when we talk about utilization, then it's the average fraction of the server pool capacity that is busy processing customers. Okay, and what I would tell you in everything that we're going to study in the text, right, our inflow rate is going to be less than our processing rate because we're saying that we have a stable environment. Okay, and the only time that that doesn't work is when you don't have enough capacity and your processing rate is less than what your customer inflow rate is. So in our case, our utilization is always going to be less than 1 because we're always talking about stable processes, right? And only time utilization, it really can't be greater than 1, but it can be equal to 1 if you don't have enough processing capacity, okay? So on that note, if our processing rate is greater than our inflow rate, the total processing capacity is sufficient to meet the demand for the service. So then our throughput is equal to the inflow of our customers, okay? And our utilization, which is our inflow rate divided by our processing rate, is less than 1, so that some of the available capacity is unutilized, okay? So if I were to ask you, from a strategic point of view, do you want high utilization or low utilization? It's an MBA question. If you're in a business, do you want high utilization or low utilization from a strategic perspective?
strategic, like going forward, you'd want low, wouldn't you?
Okay.
Because you would want to be able to expand. If you're high utilization, you would not have enough resources to expand, correct?
Okay, that's true. That's true. I was thinking of it from a different perspective, but that's true. Okay. Anybody else? Do you want high utilization or low utilization? If you were the owner of a business and you had high utilization of your employees, would that feel good, you think?
Yeah.
Generally, yes. But here's the catch-22. What are you competing on, right? Because if you have high utilization, what you're saying is that your customers are having to wait in line longer. So is that okay because of how you're competing? So it's when I say it's an MBA answer, it's because it depends.
There's all sorts of levels.
So if you're competing on cost, right, your customers are probably going to be willing to wait in line longer, right? But if you're competing on service, don't make me wait in line because I'm paying for that service, right? And so then your utilization rates are probably going to be lower because you're going to have that capacity. So it's that I want you to be thinking of it as a tool, not as a, sometimes students tend to think of, well, utilization, high utilization is always best. It just depends on what business you're in, whether or not that's the case. So we're typically willing to wait a little bit at Walmart because it's low cost, right? We just kind of accept that as part of the Walmart experience, right? But if I were going someplace super fancy, like some of the big, in some of the larger cities, they have kind of those boutique grocery stores, right? I'm not as willing to wait there because I'm paying, more money for some of that, the service and the type of food that I'm getting. Okay? All right. So when our utilization is less than 1, we're essential for stability of a service process, and if there's any variability in, it's essential for the stability of a service process if there is any variability in inflow and processing times. Okay? So as we think about safety capacity, right? So that's going to be some questions that you'll be asked is, well, how do we determine safety capacity? Safety capacity is the difference between your processing rate and your throughput. Basically, how much of a buffer do you have between how much time it takes you to perform the service and how many people are coming through that service. Okay? T sub I, okay, and as we move into Tuesday's lecture, this becomes important that you understand the difference here, so we're just talking about, we're breaking time into 2 parts. We're breaking it into the time that somebody waits, right? And we're breaking it into the time of actual processing. Okay, so and so then our total T is equal to the time that either the flow unit or the customer waits plus how much time it takes them to process. Okay. From an efficiency standpoint, flow time efficiency is the proportion of time that a customer spends being served rather than waiting in the queue. So our efficiency is going to be our processing time, right, divided by the total time. And that is it for today. That's just short and sweet. I want you to get a flavor of those terms, right? And then we're going to hit lectures 2 and 3 on Tuesday. They're both relatively short lectures too, so that shouldn't be any problem. And that being said, Scotty and Emily, we're probably done, and the rest of you, I need you to stick around for a little bit and let's figure out what your approach is going to be here. Okay?